Hi, my name is Lalit Fani Srinivas Kandaregula. I'm a software engineer at FlexTrade. I'm doing an internship in the space of AI/ML, working on the Flex One trading platform, working with L2OMS and UI team. This is my reflection video for the end of my internship term. Connecting what I all have learned in this term at my internship with what I studied in my program. I just want to walk through three things what I learned in this term, how it connects to my coursework, and how I plan to carry it forward. So, coming to the first part, when I started this internship, I understood my role pretty narrowly to build ML models, plug them into trading platforms, and so my job began and ended with model architecture, training data, and prediction accuracy. But over the course of the term, that understanding of my job duties has changed a lot. In the early weeks, I was building and integrating ML models directly into the trading workflows, like a for example like a repo trading model, an options pricing model that use Greek calculations and implied volatility, and FX spot and forward pricing models and all. But I later extended that work to more complex derivatives like interest rate swaps and cross currency basis swaps. But the turning point for me was a security audit I did on the security master file documentation, in which I went through each and every security type like the bank debt, benchmark, FX swap, CDS index swaps, and found gaps that were missing in the document, like the undocumented security types, places where the UI didn't match the API validator, and then how these securities are currently in the system, and how do we have to make sure to integrate the machine learning workflows into them. And even though this documentation made a very big it was like a very daunting manual work to go over, but then this gave me the idea of how the data governance is being you know played as an important part in the AI reliability. If a security type isn't properly defined at the point of entry, bad data can flow into straight into these ML models that I'm building, and then the model has no way of knowing the input of what was wrong in the first place. That theme kept me showing up in the second half of the term when I shifted into client escalated bug investigations a lot. One example is a client system was throwing a currency error because of a subtle mismatch, which is like in the database, the source, the USD currency object had a different decimal precision than the hard coded USD constant in our code. So, because of how Scala uses these classworks, those two objects failed an equality check, and that failure has eventually cropped up into the calculation fee miscalculation in the fee. So, like these of the things, these kind of things have popped up a lot. These kind of dramatic failures are always silent. They don't make much of the noise. They look like it's the system is working, but they silently fail them. So they are the ones that are needed to be taken care of a lot. That's why the reliability aspect of these data was one of the main parts that I worked in my internship. So, coming to the aspect of how this work connects to my studies, is in my AI coursework I've been writing about AI powered trading systems, which an AI models like XGBoost, that were the models that were built from using the algorithms like XGBoost, LSTMs, and reinforcement learning approaches, along with the NLP models like Finbert for processing financial text. So these would be helping for the user to have an AI assisted trading platform where a lot of things are pre calculated and predetermined just for the user to make sure there is high performance output from the trading aspect. So that coursework gave me the theory on how these models are structured and why they work. And uh, and in the internship, the other part of the understanding has came into picture of what happens when we put the theory into a real regulated production system. So I learned that model accuracy on paper means very little if data feeding is inconsistent, or system state around it is unreliable. So I also had to think about regulatory frameworks like Dodd-Frank and MiFID2, which require that pricing outputs be auditable and traceable. But that's not something you think about in a classroom model. It can be only applied in a real engineering decision. So, yep. And going forward, so I would want to carry this reliability mindset and into any of the AI or ML roles I take. Concretely, if I were to design a system today, I would want to build in a lightweight anomaly detection layer, something trained on operational data like order timing, locate, approval sequences, or work for abort rates that can catch these silent failures before they even reach a client, rather than relying purely on the deterministic rule based checks that could be fooled by timing or scope issues. So overall, this internship has reshaped on how I think about reliability and the concepts of machine learning and AI models, but implementing them in the real world has made a real impact for me to how to scale these things onto a reliable systems. Thank you.